Hello everybody. In this video, we'll look at question number 34 from GATE Biotechnology 2022 paper. So the question is, a fermentation broth of density 1000 kg per meter cube and viscosity of 10 power minus 3 kg per meter per second is mixed in a 100-liter fermenter using a 0.1 meter diameter impeller rotating at a speed of 2 per second. So the impeller Reynolds number is. So before solving the numerical problem in the given question, let's have an overview about Reynolds number and about why it is important. So the Reynolds number, denoted by Re, is a dimensionless quantity. It's a dimensionless constant which is used to predict the flow patterns in different fluid flow situations. So it is defined as the ratio of inertial forces to viscous forces, which is given by Re is equal to rho Vd by mu, where rho is the density, V is the velocity, and d is the diameter of the pipe in which the liquid flows, and mu is the viscosity of the fluid. So inertial force is the force opposite in direction to an accelerating force acting on a body, whereas the viscous force is proportional to the rate at which the fluid velocity is changing in space or measure of a fluid's resistance to flow. For example, a high viscous solution means that it flows smoothly, and whereas a low viscous solution means that the fluid doesn't flow smoothly and there's more resistance for the fluid to flow. So why is Reynolds number important? So Reynolds number is mostly useful as in identifying the type of a flow in a pipe or in a reactor. So there are mostly two types of flows. One is the laminar flow, so which is the flow of a fluid where each particle of the fluid flows in a smooth path where the paths never interfere one another. So the velocity of the fluid is constant at any given point of the fluid. And the other one is the turbulent flow. So turbulent flow is an irregular flow characterized by tiny whirlpool regions. So the velocity of this fluid flow is not constant at every given point. So with that said, if the Reynolds number, if the constant value is less than 2100, then the flow in the pipe is said to be a laminar flow. And if the Reynolds number is greater than 4000, then the flow in the pipe is turbulent. Whereas if the Reynolds number is between 2100 to 4000, then the flow is under transition region, and under this region it is called as the critical Reynolds number. So coming back to our question, we have a fermenter with an impeller. So the capacity of the fermenter is 100 liters and the diameter of the impeller D is 0.1 meters, and the other measurements are given in the question. So we just saw that the formula for Reynolds number is rho Vd by mu. So this is in case where you need to calculate the Reynolds number of the fluid flowing through pipes. But here in our question, we have a stirred tank. So here the formula is just slightly different. So here the Reynolds number is rho v d square divided by mu. So with that said, so rho is the density of the fluid, which is 1000 kilograms per meter cube, and v is the velocity of the impeller, which is 2 per second, and d is the diameter of the impeller, which is 0.1 meter, and mu, the viscosity, is 10 power minus 3 kilograms per meter second. So now applying all these in our equation, we have 1000 kilograms per meter cube into v is 2 per second, and d squared is 0.1 into 0.1 meter squared divided by mu is 10 power minus 3 kilograms per meter second. Now cancelling out the units, the seconds in the denominators get cancelled out, and the kilogram in the numerators get cancelled out, and meter square, meter, and meter, all of these get cancelled out. So Reynolds number is a dimensionless constant, it's just a constant number. So now solving these values, we have 1000 into 2 into 0 0.1 into 0.1 divided by 10 power minus 3. So it's 2000 into zero point 0.1 into zero point 0.1 is 10 power minus 2, and 10 power minus 3. So we have 2000 into 10. So the answer would be 20,000. So the Reynolds number for this given impeller, so the impeller Reynolds number is 20,000. So since Reynolds number is greater than 4,000, it's a turbulent flow, and yeah, so that answers our question. So the impeller Reynolds number is 20,000.